Hello, everyone. Thanks for joining us for our next live session. I'll be your producer for our session, but before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor channel. With that, I'll turn it over to our speaker for today. Thanks for joining us.
Hi everyone. Super excited to be a part of the AI Genius series. Today we would be speaking about how we build smarter AI agents with Azure AI Foundry agent service. This is Shweta Kamat. I'm a technology strategist at Microsoft. With that, let's get started. Let me move to my first slide. That is So, for example, before moving into AI agent service, what we would be doing is understanding what is an AI factory. So, think of AI factory as a system that automates and scales. Why do we say that? Because say we are not in that era right now where we build isolated AI models or isolated AI solutions. We need something like an orchestrator or a factory which creates like a fleet of agents and eventually helps us productionize our applications. So hence this concept of AI factory is very important, and hence we say that AI Foundry provides you that platform like an AI factory wherein there is a host of services under AI Foundry that you have, where agent service is one of them. What we'll do initially is try to get some overview of what an AI Foundry service is, which will help you understand the agent service better. So then let's dive in. Let me go and give you a high level overview first of what is the entire stack consist of. So let us start with the left side. So if you see, I'm starting with the leftmost side. The first component that you can see on the screen is Copilot Studio. If you have a look at Copilot Studio, it is more like a no code, low code platform that you use. So on the Copilot Studio, you have a UI. You can directly go and click on the create button, and you have an agent which comes up. So you can just give instructions in plain English language, and an agent gets created for you. What that helps is, first of all, a lot of people who want to cut down on their development time, or maybe also give this access of creating agents to people who are not core developers, but do understand development to some extent, or English language and know the domain well. So Copilot Studio is for those kind of users. Copilot Studio is a beautiful tool because somehow it also allows you to integrate with AI agent service, which I will speak about later as well. So basically, it's somewhere sitting in between, and it helps you integrate the low code and the pro code environment. So that was Copilot Studio for you. Let us move to the second icon that we see on the left. That is Visual Studio. What is Visual Studio? Visual Studio is basically a developer platform, but completely fused with AI. What it helps you to do is it helps you to develop. And again, there are so many AI assistants within Visual Studio. There's a Copilot which helps you code, and a host of extensions within Visual Studio, which again we will deep dive into later, which really fast tracks your development and greatly assists you in your development process. So that is Visual Studio infused with AI. The next icon that you see here is your GitHub. So we all know GitHub, and we all know that GitHub has like changed drastically over time. So while GitHub is a tool that you use for collaboration, for version control, for sharing your code and all that, again there are a host of AI capabilities that have come into GitHub, which really fast tracks your process and helps you collaborate with AI. And the last icon that you see over the left side is the Foundry SDK. So if you see in the Foundry SDK, basically the same thing that you see in AI agent service, there are APIs where you can actually connect to a host of external systems. So Foundry SDK is more like the API or the pro code way of developing an AI agent service. And again, we'll come on to it later when we come to the demos. Now let's move to the central part of the section, that is what you see under Azure AI Foundry. So I will start with the topmost, that is the Foundry models. So when you go on to a Foundry portal, you see that the topmost point is the model catalog. Within the model catalog, you have like a host of models from which you can choose from. Now, those may be OpenAI, non-OpenAI, Hugging Face, DeepSeek, all sorts of models available. So there are more like thousands of models available from a Foundry point of view. So you don't really need to go out, you get everything under one umbrella. So that's the first thing, that you need models. The second thing below that you can see is agents. So agents is our topic for today, which successively we will deep dive on. This consists of a lot of many types of agents, agent service being one, and then you also have the agents that are in semantic kernel and so on. Beneath the agents, the next thing that you can see mentioned at the left is Azure AI Search. Azure AI Search is basically, I would say, it provides you, it's again a very unique tool because it provides you a combination of keyword search as well as vectorized search. So it's more like a hybrid search offering that we have, very suitable for AI use cases to actually create vector stores. At the same time, wherever you have use cases where you need fast search retrieval, all those cases are actually satisfied using Azure AI Search. The next thing that we go to, if you see, you have Azure AI Services. Azure AI Services is nothing but the entire umbrella of AI services that are present within Azure. So basically, you have cognitive services, you have speech, text, you have OCR capabilities, you have so there's something called as document intelligence, content understanding. So a host of services out there, everything combined under one umbrella, very easy to integrate with the rest of your application. Moving next, if you see, what you can see there is a Azure machine learning component. Again, a complete end-to-end stack to do machine learning. So everything from an ML ops, AI ops, all those things can be done in machine learning. And the last part that you see is Azure AI content safety, which I will also show you a short flavor in the demo, wherein you can actually, whatever output is given to you by your AI models, you can actually evaluate them to see if there is any harmful content, any offensive content that is there. So these are like the built-in capabilities within Foundry and the Azure stack. So you don't have to do anything out of the box to actually do an end-to-end application development on AI. Once we have completed the content safety part, if you see below, there is uh, like a platform sitting down, that's the observability. So what Microsoft has done is that for the entire stack that you have on AI, you have an end-to-end observability platform. So everything from tracing your applications to seeing how the spans are, traces are, and how the flow happens, all of this is included in your observability stack and everything. So if you see within the entire stack, Microsoft does stress a lot on security. So there is a lot of focus to see that the entire stack is secure, the way the data is provided to the LLMs as well as the output that is received, all those need to be very secure and governed. So security and governance is the underlying factor that you would find across Azure AI services. So now, having a brief overview of what we have in Foundry, I'll move to the last section that you see on the screen on the rightmost. So let's go from top to bottom. The first thing that you could see is Azure. We all know Azure. Azure is the cloud. So basically, the AI agents service that you spin up, all those are on Azure. The second thing that you see below that is Azure Arc. Azure Arc is like a unique offering wherein it helps you in hybrid management. So basically, you can combine non-Azure environments into Azure. So basically, you can create an agent in Azure and then maybe link it to something on-prem. So Arc helps you in actually connecting the two environments. You could call it as a connector. Below that, you see a Foundry Local. Foundry Local again is a unique offering wherein, say, you have something running on the edge, and you do have AI use cases on the edge. So Foundry Local is something that can connect your local edge environments to Azure. That is one use case. The other thing where we see there are a lot of regulated industries where not all the code or not all the data can move on cloud. Foundry is a very good example for Foundry is a very good tool for these use cases. So there can be a lot of data that sits on your regulated environment, and only some of it can go to the cloud. So that's Foundry local. So if you see the way the arrows are, you can see the arrows bidirectional between the edge and the cloud. What that means is that something on the edge, you can do the processing, send that to cloud. On cloud, you can either process it further, you can store it, you can do analytics on it. What does the arrow from cloud towards edge mean? It means that decision making can be pushed to the source. So if you have something running on edge, you could have decisions from the cloud that flow through the edge. So this is overall what the stack looks like, just a big quick overview of Foundry. Now let's move to the next slide. What we have next, and let me move there, is Foundry agents. So basically, this is the topic for today. So we've just going to highlight on while we spoke about how the entire AI stack looks like. Today we will focus especially on Foundry agents. Let's come to the first section. That's a quick introduction of agent. So, what is an agent? An agent is a semi autonomous software that can be given a call and will work to achieve that goal without you knowing in advance exactly how it's going to do that or what steps it's going to take. So, traditionally, what used to happen is that we used to know that there are, defined steps. So, if there is a process within your organization, you know that there is a step A, there is a step B, and a step C, and you know that it will go in this order. But it was something which did not have a brain of its own or the capability to think on its own. What agent has bought is this autonomous capability where it can also has a brain of its own, while humans do have the ability to intervene in between, which we call human in the loop. But agent is something that can really fast track and automate processes to a lot of, to quite a lot of extent, because this is what it brings in, the autonomous capability. Now, an agent needs to accomplish three things. First is reason over a provided business process, then retrieve the context to complete that process. So when actually the first time you tell the agent, you give the agent a task, it reasons as to what it needs to do in that process. The second thing that it does is it tries to retrieve to complete the process. If you have, say, for example, a database or data source, some files, it tries to retrieve context so that it understands further on how to execute the task given by you. And the last step is definitely to perform an action for the end user based on what has been told to it. Now, let's further deep dive into what we call the anatomy of an agent. So, again, going from left to right, if you see the leftmost part, you see a box called input. Now, what is input? Input has system events, that is, some basic instructions that are given to the agent. Next, so these events could be some guardrails that you set for the agent that you should not be going out of this context. So that's what system events mean. The second thing that you have is user messages. So user messages is might include the specific task that you're giving your agent. And then there is an interesting component that you see there called agent messages. So what is agent messages? Agent messages is so this is the agent messages that I was referring to. What is agent messages? Agent messages is when you have, not always you have a single agent running, for example. So you might have connected agents, you might have multi agents in a scenario, and agent messages might mean messages coming from other agents. Now, when these come to this box as input, if you see within that agent, you have an LLM model sitting, which gives it the intelligence. Then you have the instructions that it received from the input. And then there's an interesting thing at the bottom that you see, that is tools. So what are tools? Tools again are something that you can connect your agent to. These are more like, you can say you help the agent assist by giving it a tool. So for example, you can give it a tool to connect, say it's so you have a tool like a calculator, for example. So you give it a tool called calculator, which helps it to do mathematical operations. Similarly, say you give it a tool, I have a tool called a database connector. So I can give that tool to my agent so that it becomes very easy to connect to databases. It does not need to think of how to connect. So these are some of the examples of tools. So basically within tools you have retrieval, wherein a tool can help retrieve data from some external system. Then you have actions, wherein you can maybe perform some actions, also connect to downstream systems, existing applications. And then there is the third thing that you can see here, that is memory. So again, memory is something which in there are various types of memory, and that again is a subject in itself. But you have short term memory, you have long term memory. So an agent, how it stores the memory, how it can retrieve it, how does it remember what time, what was done last time. So all these come under these tool calls. And now when an agent gets the input and it gets tool calls, what it does is it processes the combination of these two, and what you see on the right is the output. Now again, very interestingly, output could either be results of tools, that is, the result that is expected to for the agent. But in most scenarios, your task is not complete with a single agent. And what these means, that the output again might be an agent message which you will pass on to some other agent. So this is how typically an agent functions. Very simple. You have an input, you have tools, and then it gives you an output. Now let's move on to the next, a slightly getting deeper into this. So if you see, this is the multi-agent orchestration. So while I was telling you that not always you have only a single agent, you do have multi agents in most scenarios. So there are various design patterns, two of which are shown here. So one, the first thing that you see and which is available right now in AI agent service is connected agents. Connected agents basically gives one agent the abilities of another. What does that mean? So basically, I there could be a sequential process where one agent connects to the next agent, and so on and so forth. So this is what can be done in connected agents. And the second thing that you see is multi-agent workflows. So multi-agent workflows means that you can orchestrate multiple agents. There are a lot of design patterns, if you've heard of orchestrator pattern, supervisor pattern. So all those different patterns wherein you can have one agent calling agents in parallel, and all those various kind of use cases can be implemented. So with that, we finish the first section of our session, that is the introduction. And now we move to the second section, and that is building. So if you see, let's go into how do you build these agents, which is obviously the main topic of our session. So going on to the various ways in which you build your agents. So let's go again from left to right. So first, what you see on the left is IaaS, that is infrastructure as a service. So what you get here is Azure infrastructure, and here you get your own framework. So this is like the lowest level where you have complete control, visibility, and customization. So if you see, there's an arrow that runs here which says that this is highest when you go for an Azure infrastructure, highest level of control, highest level of visibility and customization. Similarly, if you see here, okay, there is the lowest level of ease of use and development speed. What this means is, since your customization levels are high, when you actually go for infrastructure as a service, there are a lot of things that you have to do yourself, which means that the development time increases and the ease of use decreases. So there are pros and cons of each way of development. When we go to the next, that is platform as a service, this Azure AI Foundry is an example of PaaS service. Foundry agent service sits within the Azure AI Foundry. And here, if you see, it sits somewhere in between, where you have typically a very moderate development speed. It's easy to do it, not that difficult as such. And you also have a fair degree of control over what you do. And then you move to the right, that is software as a service, which again, Copilot Studio that I was mentioning earlier is a classic example. You can, and what you can do in Copilot Studio is it has an agent runtime of its own, which you can use. And it's more like a drag and drop UI building. So easiest to use, fastest to develop, but customization control wise, it would be lesser as compared to the other two that we see. So now, with this introduction in place of Azure AI Foundry and what are the various ways you develop an agent, let us deep dive into our topic for today, that is Azure AI Foundry Agent Service. So this is generally available in Azure, and it can be used to orchestrate and host single and multi-agent workflows. So multi-agent workflows are a capability, open and interoperable tooling, so it can easily connect to all the available open source protocols. And since I mentioned earlier as well, it is within Azure. Trust and security are prime focus for this service. So while Azure does allow you to connect to all the open source protocols, there are enough handles in place to ensure that security and trust are maintained. Now let us go to again each of what this full enterprise package consists of. So if you see Azure AI Foundry service, let's now go to the leftmost part, that is trust. Like I was saying, that there is customer control over data, networking, and security. So what that means is that you can control it to the highest level. So for example, bring your own file storage. So you can specify the file storage, you can specify the search index, the virtual network, the thread storage. So basically it uses a Cosmos DB at the backend. So when you actually, you can specify your own custom Cosmos DB for storing the thread integration and the auth integration. So if you see from an auth perspective, very easy integration with Azure AD or any OAuth tools that you have. So very easy to integrate on that perspective. Now, when you come to the central part, this is the choice part. So, like I was saying, a host of models available. So, if you see, you have Azure OpenAI, you have Llama, you have Mistral, you have Cohere. So, all of this again, from a choice perspective, I think almost all models are covered out here. And the last part that you see to the end is the tools part. So, I will show you again when we actually go into the portal, but you have the capability of adding knowledge sources. So basically, if you've heard of the first icon that you see is Microsoft Fabric. So if you've heard of Fabric is the lake house, typical lake house story that you have. So if you have something sitting in your data lake, agents can easily access it because there's a ready-made connector available for AI agent service. Similarly, you have something sitting in SharePoint, you can do that. Microsoft Bing is now integrated, so all Bing searches easily build agents on top of it. Cognitive services, again, easily connect to any cognitive service that is available within the Foundry. So from a knowledge perspective, rich set of connectors and tools, you don't need to do much. You just have to click a few buttons or write a few lines of code to get these connected. And similarly, if you see from an actions perspective, a lot of options, like you have once you have to execute something, you could either use a logic apps or an Azure functions or open API. So open API means you can actually integrate with any of the REST use cases. So all this makes it pretty simple because a lot of connectors are present. Even the actions that you have to take are all well integrated, so very easy to use service from that point of view. So now covering Azure AI Foundry agent service, I think uh, move on to we can now move on to our next section, that is moving into a few of the concepts out here. So basically, we see what we have now is MCP. So everyone has been talking about MCP. We all know it. It stands for Model Context Protocol. So if you see the diagram out here, what is shown here is an AI application. Now, an AI application can connect to a database. It's shown you can connect to web APIs, you can connect to some communication platform like Slack, you have local file system, you have Gmail, and you have GitHub. So what this figure represents is that with MCP, now you can connect to almost every kind of data source. Now, what does it mean for us when we build agents? So let us take this simple example of GitHub here. So when you see GitHub, you see that like if I will show you in the demo as well, like Azure documentation also has a MCP server. Similarly, if you see now GitHub has an MC server. So MCP server connects to GitHub using a web API, and then using MCP protocol, you can easily connect agents to GitHub server. So all the development becomes really simple, because in earlier times you actually had to go and see what is the API, what is the API definition, connected, give the exact syntax. Now it's not the case. If two systems actually comply to MCP, it becomes very easy to integrate with all of them. Again, now moving to the interoperability, similarly, if you see Azure AI Foundry sits at the center, and you have the Assistants API, the Responses API, A2A, Agent Protocol, MCP. So, what this figure actually represents is that it is very easy to connect with the agent service. So, if you have agents which are sitting externally, so if you see at the left, you can import an external agent. What that means is I have developed something in, say, Llama or Crew AI. It's very easy to integrate that within the Foundry agent service. Similarly, if I want to expose my Foundry agent service externally, that again is possible. These are the APIs that allow you to do it. Assistants API, Responses API by OpenAI, which are present. You have A2A, which we know is the agent to agent protocol. So that again makes it very simple. MCP, like we just discussed. So all of this kind of makes it very flexible, easy to integrate, and with the kind of environment that we are now in, where everyone uses, like there are a host of frameworks, and even within one organization there may be different teams using different open source proprietary frameworks to do it is very easy to use Foundry agent service from an interoperability perspective. Now, with all this said, I think we now move to our first demo, which is the first one, that is the MCP part. So let me just run it, and as I run it, I will also start speaking about it. Um, yeah, so maybe I will play this. And as I play it, you can see here that what have I done? This is an MCP support that is shown here. So like I was saying, the use case here is that there is a Azure documentation which already has an MCP server. And what I'm trying to do is I'm trying to connect an AI agent to the Azure MCP server URL. And what that does is that I then can very easily converse with the documentation. I would rather put that, because if I have to now ask it a question on any Azure services, like what is the difference between OpenAI and Azure OpenAI, what we would typically have done is we would have gone and searched in the documentation of where that is written. Now what is happening is it's become like a chatbot for me. So let's go through this example of how this is done. You see, the code is very simple. It is very few lines of code, which actually connects your AI agent service with the documentation URL. So we've done a pip install here. This code is written in Python. And then you see these are the import statements. This is the MCP URL. And now if you see here, this is the portal. So basically, I've shown from the start that you would need an AI model. So this is how Foundry looks like. And I will also come to that in a minute. So I've already created a deployment of GPT-4o Mini. Now, this is the model that I am using for my use case. So here I come to Foundry, I create a model deployment, and then I use that. So if you see, this is GPT-4o Mini. This is where I can see the URL, the keys, and this is what I have used in my project. And then I come back here. You see, I have created an MCP tool. I have also created what is called as an AI project client. So this AI project client is nothing but a programmatic way to connect to my Foundry project. And within the Foundry project is what resides is my agent service. So I think I'll just continue the demo. So basically, we were here somewhere, and what I will do is I will run this. And so, if you see, it is still running. I have created agents, I have created threads, and then you see, this is the entire code which is there, which shows that how the tool calls have been made. And if you see here, maybe here I will pause, and I'll go a little behind and show you that what is done here is just go through this code. So basically what it says is that agent has been created. This is the MCP server, that is MS Learn. This has been published. Then I created a thread, I created a message, and then the run starts. And once the run completes, you can see that the tool calls happen. And if I play that again here, you can see this is the output. So what I asked my MCP server is, what is the difference between Azure OpenAI and OpenAI? And what it did is it went through the documentation and it got me this like a chat. So it's as simple as this. What it helps me now is converse very easily and integrate with almost any other service present here. Okay, so I'll just complete this demo, and this is a simple example of how MCP server can be integrated with Azure AI agent service. I've just run all notebooks here, and if you can see, I can just go a little further. This is that I've done a run all here. And now let me come here. Now this is interesting. Now you saw that what I did was I programmatically created an agent. Now let's see if we can see that on the UI. So when I come to the UI here, this is the aiazure.com. This is the Foundry URL, and this is how it looks like. So like I was explaining, you have a left pane and you have a right pane. So if you see here, you have a left pane here, which is the model catalog, playgrounds, and this is where you can see agents. So I again go back to my demo. I continue my demo. Maybe I have to shut down my laser. And that's how I think it's because of my laser. Let me just shut it down. And here I go. I play it back. And you can see that now you can see your agent created. So the agent that I created on programmatically now appears here. So you can see this is the MCP agent. And now if you see on the right, is where I can actually see my MCP agent created, and all those instructions that I gave programmatically are now, you can now see it here. Okay, so this is how it's done. And you can see the various options. We will also go through the UI where I will show this to you again. So now this was the first demo. So now let's go deep dive further. This now we start with the third section, that is the development section. So now we saw programmatically how this could be done. So the first option that you see was the Foundry API and SDK, which was what we used here. We also have another way of building agents, that is using the Visual Studio Code extension. And the third way that you could actually develop agents is using the Azure AI agent service. So I'll just quickly show you this. This is the second demos in this session. So this was the first way. And the second way, let me go to the next demo, and then you'll see the Visual Studio Code integration. So Foundry SDK, we already saw Python.NET support already there. We had seen an example in Python. Later on, I have an example in Python as well as in .NET, just so that you get a flavor of both. This is about the Foundry SDK. So if you see, these are like some simple descriptions of keywords. So basically, agent is a custom AI that uses models in conjunction with tools. Thread is a conversation session between an agent and a user. So threads store messages and automatically handle truncation. Then you have a message which is created by an agent or a user. A run is nothing but every run that we do, right? Activation of an agent to begin running based on the contents of the thread. And then is a run step, which is like a detailed list of steps that the agent takes as a part of the run. And to support the Foundry SDK, you can use grounding with Bing search, you can use Azure functions, code interpreter, file search, two concepts. So basically, code interpreter is nothing but when you actually want to do some analysis on code or such things. File search is, or maybe graphical, so something on those lines which are more analytical is when you go with code. And file search is when you actually give it files like PDFs and you have to do a file search. I'll also show you the option on the UI. And then there is Azure search, which we spoke about, and then obviously you can connect it to MCP service. So if you see this, go to the next slide. This is the Azure AI Foundry extension for Visual Studio Code. And maybe we'll go to a short demo now, which shows how you connect um, the Visual Studio, Azure AI agent service through Visual Studio. So going to the next demo, and let's play this. So this again, to start off with, this is the Visual Studio Code interface. This is how Visual Studio Code looks like for those who haven't seen it. At the left, you can click this. Okay, so let me put a pointer here so that you understand. This that you see here is the extensions. So you have to click on this, you get extensions, and you type Azure AI Foundry there. When you type Azure AI Foundry there, you can actually go and install the Azure AI Foundry extension. And then what happens is, here you can now see in the demo, what I have done is I have installed this, and you can directly access AI Foundry through the Visual Studio Code. You don't need to go to the browser. Here you see at the left are all the available plugins that I extensions that I have. The one that I have clicked on now is the AI Foundry one. And here you can see the models, you can see the agents. So if you see, that's my model deployment. You also see my agents, my MCP agent and all the other agents. And this is the screen where you create a new agent. So basically you can say AI Genius agent, and this is the model that you use, and you can actually go and give instructions and create. And if you see here, this is how it goes. And similar way, like we did it through the UI, the same thing you can actually do using Visual Studio Code, same options available. And you can see that programmatically you also have something on the left that is showing you. So you can either use UI, and when you say update agent on Azure AI Foundry, you can actually go and see this agent. So this agent actually gets created in your Foundry project. Same thing you can also view through the Azure portal as well. So if you see, this is the agent created. You can open a playground here. You can actually chat with your agent. And if you go to the Foundry portal, you can actually go and see the agent that you created. So if you see here, you can see the AI Genius agent that has been created. So one way we saw in the first demo was using the SDK. The second way that we saw is using the Visual Studio Code extension. Now let's go further. When we do this, uh, we come to the third part that we had seen in that slide, and that is through Procode. So if you see, there are two options that you can see on the slide. One is single agents and one is multi-agent. Okay, so both options are available in the Procode way. First one, it says that you can deploy agents with Azure AI Foundry, and the second part, very interestingly, it says orchestrate them together using AutoGen and semantic kernel. Now, what is AutoGen and semantic kernels? AutoGen and semantic kernel are open source frameworks given out by Microsoft. AutoGen earlier was more research oriented. Semantic kernel was the most production ready and stable SDK. But eventually, with the maturity that we have achieved in agentic space, we are now going to merge the two. And so henceforth, very soon going forward, semantic kernel will be the way to go for all agentic framework development. And now we'll see how, so we'll see a demo on how we manage AI agent service using semantic kernel. Again, there are two options, that are two versions that I have put in. One is a Python and one is a .NET, and one is a single agent and the other is a multi-agent. So let me directly jump into the demo. Here, if you see, and let me play this. So what you see here is a single agent. And the use case that has been considered here is that of a furniture assistant. So basically, what this agent does is that I have given it a picture of a room, okay, a living room, and I am telling the agent to actually go through it and give me suggestions on the room. So I have uploaded the image, which I will show you in the demo. It identifies the furniture elements and provides purchase or placement suggestions. So that's what it does. This has been developed using semantic kernel, and this is a single agent. So if you see, this was the use case. This is the picture that I have given. So this is the living room photo, and this is my code. Now I run the notebook, okay, and you see that I just go down. I have done a pip install, and beyond that, when I move down, I have actually written the code of the agent. Now this is all semantic kernel, but programmatically, the endpoint I have given, this is the model endpoint. I have created my AI project client here, and you can see that once the client has been created, I am uploading the file. Now this is the image file that I have uploaded to my agent. And then here is the create agent where I create my sales assistant. And then what I have done is, again, I have linked my image to my agent. Then I create a new agent, a thread, and a run, that is just to run the agent. And you will see that below it is now running. So if you see the message, the run status is in progress. And now if you see below is the output that I have received. So if you see, these are the recommendations that it has given, that this is how the lighting should be, this is how the curtain should be. So these are the suggestions that have been given by my sales assistant. So if you see, based on the prompts, my agent is now acting as a, say, furniture sales assistant. Now let's move to the portal. You can now see, similar to how we saw in the earlier demos, that the same agent that I developed using semantic kernel can actually be seen on the UI. And if you see, here is the thread. So every thread is a run of the agent. I can now open this thread in a playground. And if you see, this is where I can see the output. So everything that can be seen in my code can also be seen here. So these are the thread logs. This is where your observability, tracing, all this comes in, where you can see the input output, you can see the metadata, you can see the evaluations. So you can really go deep dive into how your agent has executed. Now with this, this was an example of a single agent. Maybe I now go to the next example, that is a multi-agent scenario. Now let's play this. So now again, what is the difference between the previous demo and this one? Is that now here there are more than one agents. Okay. So if you see, there is a sales agent who can analyze the furniture images and provide detailed product recommendations. There is a price agent which can process the sale analysis to generate comprehensive pricing and budget plans. And then there is a PDF agent who can create a professional PDF quotation based on combined analysis. So you can see that it has now matured from a single agent working to multiple agents working. Now, in this scenario, we have created a sequential multi-agent workflow where these three specialized agents are working together. So every agent has been specialized to do the job it has been told to do. So if you see the workflow that you can see on the screen, there is an input, which is a furniture image that is given. It is given to a sales agent, which analyzes the furniture images, then passes it on to the price agent, who passes it out to the PDF agent to create a professional PDF quotation on the combined analysis. And the output that you're expecting from this multi-agent scenario or this multi-agent use case is the PDF quotation. So this can work seamlessly without any intervention of a human being in between. And so you can just like upload an image, the agents work amongst themselves, and they can actually generate a PDF quotation out for you. So if you see here, I just play this, and you can see that, yes, Here, these are the options, and this is what I told you. These are the various agents that are being used. This is a sequential workflow process. Also mentioned the architecture. This is how it looks like. This is how the placement of the files is. These are the agent specifications, and there is also a GitHub link which you can use. You can go and look at the code that has been done here, and then see, this is the repository, and then beyond that we run this code. So this is just going through the code. This is the output examples, and these are the configuration options. So it's basically like running any other .NET project. You open the terminal, you put in the commands out there. So I'm just going to the folder, I do a cd command, and then this runs. So basically just running like any other .NET code. And what you can see now is that the code is getting executed, all these agents are getting spawned. So a build succeeded. Now I actually go and do a .NET run. And here you are, you created the agent, you created the pipeline, you are initializing the sequential agent pipeline, and it is now going to execute step by step. So basically, step one, sales agent analysis, processing the furniture image through AI vision analysis. So all these tools, so whatever concepts we saw earlier, that is, it connects to various tools, and it connects to inputs, connects to messages from other agents, and then it starts giving the output. So now the first agent has done its job, given the placement suggestions. Now the price agent analysis is actually processing the sales analysis for pricing and budget planning. And so, and then it has now come to step three, which is the PDF agent, which is actually now generating the quotation. So you see, it's like a completely automated process where the agents are working amongst themselves. It is as good as a human team working. And you see the template has been provided, that what is the template in which you need the PDF quotation to be generated, and a professional PDF will be generated out of this. So if you see, it's now completed, and we can actually go and check the quotation. So this is the code which was used, just quickly showing you the code, how it's written. This is the agent base, just going through each of the files, and you can see that if like you're already a .NET developer, it's the same thing. These are all the programs that have been written, and you have a multi-agent code written here with the input output path and the instructions given. And here you see, you can go on the screen similar way, like we saw earlier. You can see that these agents have been created in the Foundry agent service. So here, even the prompts that you gave in the form of instructions, all these are populated. You can see that these agents have been now developed using semantic kernel. So, and these are the threads. If you see every thread, you can analyze that, what went behind, what has happened, what is the output, input, all those things. Every thread can be analyzed out here. And then if you go to the output, now this is what I was mentioning to you, that you can actually see. So what has been created here is a quotation. And this is absolutely fantastic. Like if you see, I've given it the template, and it has actually come up with the quantity, the price for each of these items that it can see in the image, and it's like ready to be sent. This is the furniture quotation with terms and conditions. So this is um, this is how it looks like. Yeah. So this was an example now of multi-agent. And what I can do quickly is also show you how I can how the portal looks like, just for a very quick show of the portal. So if you can see my screen right now, this is how the portal looks like. We've already seen it. But now say I click on the new agent. I just wanted to go through every individual component that you can see on the screen. So basically, if you see my screen out here, I've just click on the new agent. So, and what I do here is I say try and playground. So when I do try and playground, this is how my agent looks like. I can actually now see here I have selected my deployment. This is the GPT-4o mini deployment that I have. Here is where I give the instructions to my agent that, this is what my agent needs to do. And then here, if you see this is the knowledge part. In the knowledge, I can actually go and add what different types of knowledge sources that I need. So all that we saw in the PPT, I just wanted to show you quickly how that actually looks like on the portal. So basically, I can connect to each of these services. This is the Fabric data lake. This is the SharePoint. You could upload local files. This is possible. And then here is the actions part, which we also saw in our slides, wherein it says that you have a code interpreter, you have open API support, you can connect to a logic apps, and then if you go below, this is the connected agents part. So basically, here is where you can actually go select another agent that you want to connect to when you want multiple agents to work together. So all this also can be done from UI, from code, whatever you're comfortable with. And here, if you see, like, let me again go back here to agents. I will show you one of my existing agents. So basically, is it this one? Let me go here and let me open this in playground. Let me see if I've already asked it some question. I should be able to see some thread logs, haven't I? So maybe I just ask I plan a trip to Australia. Maybe I just say that it starts running. I say you are a friendly travel assistant, for example, and and then I say ask this question to my agent. And so what it does is I just want to show that what happens. So see, basically it has started planning my trip. It is telling me you have to go for 14 days, 15 days. And then let me see if my thread logs are generated here. So oh, it doesn't have, yeah, here it is. So basically if you see what input I gave, what output I gave, what is my metadata, this is the run that we were talking about. So it also gives the details of how many total tokens, input tokens, output tokens. This is, you can still go deep dive, and go into a lot of features and all this out of the box. You don't have to actually build something separate to do all of this. Evaluations, so like the content safety and quality and all that, all this, it also gives you a score for your evaluations. What is it with from the risk and safety perspective, how is it from code vulnerability perspective, AI quality, all this you can see is actually inbuilt. And here, though I have now created it using UI, you can also click here and say view code, and you could see the code in here. So it's up to you, whatever you're comfortable in, either build it through UI, build it through Visual Studio Code, build it to semantic kernel. Various options are possible. Here you can go and set the filters. Here you can go and set connected to your databases, and here you can go and set voice playground. Just on an ending note, so while you this agents is what you have created, you can use the rest of the ecosystem in the Foundry to actually build your observability monitoring for your agent to a very, very granular level. So you can actually go and trace what every agent is doing, how it is utilizing the LLM. So the entire Foundry umbrella makes it like an end-to-end system that you can use to actually um, create your agents and do the traceability monitoring. So with that, let me just go back to my screen. I think I could take some Q&A, and let me just see if there are any questions. So I see a question. Yeah, agent messages, is it supposed to be a system message? Yes, it'll be a combination of system messages. Like I was saying, it could be a combination of all of it, agent messages. So not only system messages, it could be a combination. What is MCP? MCP stands for Model Context Protocol. Model context protocol, you can search for that. It's an open source protocol, and you like there are a host of use cases where now the entire world is kind of thinking in directions where your existing APIs can actually be converted into MCP servers, makes it very easy to connect and work with. Then this I can see any more questions where we can get these APIs. I'm assuming it is SDK APIs. You will find it. I mean, it's all available in Azure documentation. If that was the question, where can we get these API? Then I see a question. If we use the concept of sequential orchestration, then would it still qualify as agentic? Agentic is where we leave the decision with the orchestrator agent, and this invokes the AI. Oh yes. So see, basically, sequential also is a pattern. It doesn't mean that it is like a hard-coded pattern. Okay. So we are just handing off to an agent. So think of it like this. I already have a process wherein, say, I have a process where it moves from process A to process B to process C. Okay. In our traditional systems, that is where how it would have been. When you see here, when I say that I have agents running in a sequential process, does not mean that that agent will do defined processes. Okay, every agent is intelligent enough to choose. So I can just tell an agent that, like you saw in our multi-agent step, right? Whether it does the analysis, whether it creates a PDF, it is still an independent agent to take its own call. So it is agentic, definitely agentic, because every agent has a brain of its own, can use tools of its own, and take its own call. So it is autonomous. It's just that it's called one after the other. That's a handoff pattern that we call in OpenAI. But yes, it is definitely agentic. And just for anyone who's interested, there is also something called as process framework in semantic kernel, and that again is something that if you want to replace some of your existing processes, you can consider. uh, are MCP messages passed between agents? Let me put it this way. MCP is more of a context protocol, and there is also a concept of A2A where agents communicate with each other. So it would be a combination of MCP and A2A. But are the messages, so there is definitely communication happening between the agents, yes, and it'll be a combination of MCP and A2A. What does it take to build an agent which can go through my SQL Server database and give answers? Oh, great question. So I can think of multiple ways. One way is that I have an agent and I create a plugin, okay, a semantic kernel plugin, which can connect to a database and hit the database, query the database. A more sophisticated way to do it will be to build an MCP server on my database, and semantic kernel has inbuilt support for MCP. So connect to the MCP server of that database and then query the database. So I think that would be a more sophisticated and better way to do this. The next question I can see is VS Code and semantic kernel comes under pass development. Um, Yeah, I mean, basically, it could be so semantic kernel in itself is an open source framework. So this is like something that you could use anywhere. So it's not like that semantic kernel can only be used on Azure. It's more like an open source framework. If you've heard of Crew AI, if you've heard of LangGraph, uh, if you've heard of any of these open source LangChain. So semantic kernel is just like that. So I would say it comes more under just an open source framework, which you could also use on IS. You can just spin up a VM and put your, so like you saw the code, it is just a code in Python or .NET that you can put anywhere. When you integrate semantic kernel with an AI agent service, and that agent gets spawned in Foundry, then yes, it becomes a pass because AI agent service comes in that category. But if you're using semantic kernel standalone, it can also come in infrastructure as a service. So yeah, using SDK is like IaaS, using UI is SaaS. Yes, so Copilot Studio, like we discussed, is SaaS. Um, can you more explain about the licensing part? So we discussed various things. So I would say everything that we discussed today, like even Copilot Studio, even AI Foundry, there is no licensing involved. It's all pay as you go. Think of it as AI Foundry, especially think of it as any other managed service on Azure. It is similar to using an Azure Functions. You just go spin it up, use it. So while there are options which, like for the models, you have something called as provision throughput unit, which we commonly refer to as PTU, where you can reserve. It's like on a reservation basis. There is no license involved here. And the same applies for Copilot Studio. There is a concept called message pack, but all again is pagey. You can spin it up, no license is required. Next question I can see is how can we integrate these agents in other applications? A very good question. SharePoint, Power Apps. Um, Let me put this way. Uh, these agents can easily integrate, like you've seen, there's integration with SharePoint. You can take these as knowledge services, knowledge sources, right? So you can integrate with any of the existing. Here you've just asked about Microsoft ecosystem. So yes, you can integrate easily with each of these. These have inbuilt connectors. So anything with the Microsoft ecosystem definitely has an inbuilt connector. Anything apart from that also, if you want to use, there are REST APIs or open APIs that I showed you earlier. So easy to connect to any ecosystem for that matter. Moving to the next question, can we use our own documents like PDF text to train a model and use in AI Foundry? I need to build an agent which uses only those documents as knowledge base. Oh yes, this is possible. So if you saw when I created an agent, I had the option to choose my model deployment. So in that part, you can actually go and put your own model. So I just took a GPT-4 or Mini to keep it simple. Um, there are customers who actually create small language models, fine-tune models, and then use agents for those specific use cases. Like say, for example, if you've heard of loan underwriting, for example, there are organizations who might need a special small language model which can do the underwriting process for their organization. So in such cases, basically you build a fine-tuned model or an SLM, and then you connect it to your agent. So yeah, this is possible. Next question that I can see is, can an agent created in Copilot Studio? Oh, great question. This is perfectly possible. So basically, it's very easy to create an agent in Copilot Studio and an agent in Azure AI Foundry, connect the two. Lots of patterns available and on that part. If you want, you can even build a chainlet UI on top of that, and these agents can converse with each other. This is possible. There are examples, GitHub repos to support this. Next question, agent code in UI will generate only. Oh, so I think the next question, agent code in UI will generate only a .cs file. Is it created Python version? So I showed you two versions. Those are basically interchangeable. So you could create code in Python, or you could create code in .NET. So the .cs files that you were seeing was .NET code. The same thing has an equivalent in Python. So it's possible. Both are possible. The next question that I see is to pass through SQL database. I didn't quite get the question. I can see it's only written to pass through SQL database. Not really clear what the question is. Maybe moving to the next question. Does creating multiple agents cost extra? Or is the cost only based on the underlying model usage? Also, if you use agent service, yes, there will be some pricing. You can refer to the pricing calculator. So it'll be only on usage basis, basically. Whenever you use that thread is when you will be charged. Next question. I have a multi-agent that connects with students. I hosted it. I used Twilio, WhatsApp, SMS. I hosted it on Azure VM. Can Foundry help to have a uh, better performance? Uh, yeah, definitely. Because see, Foundry eventually, if you see, takes care of a lot of stuff, which on a VM. So, what you refer to as VM comes, if you remember the slides that we went to, comes to the leftmost part, that is the IaaS part. Infrastructure as a code, where on a VM you are managing everything yourself. So definitely, if you move to Foundry, a lot of things will be taken care of it, and it'll lead to better performance definitely, because um, scaling and performance on a managed service is way better than running on Azure VM. So the answer is yes. Um, Moving next, all agents created using SDK or programmatically will be available. Oh, yes, all agents created using SDK or programmatically will be available in AI Foundry. Yes, all agents will be. The next one, are there any dedicated cost estimation tools for AI Foundry and associated tools? Okay. Let me rather put it this way. We will the not the cost, but you can see the usage and you can calculate the cost. So basically, how many tokens, like I showed you, the usage of the models, they can all be seen through the UI, and then you can estimate the cost. Going to the next question. So MCP servers can be created from a web API or object library automatically. See, MCP, I'm not sure what you mean by automatically. There is one way to create that automatically on Azure, yes. If you've heard of a service called Azure API Management, which is the API gateway, you can actually, on the click of a button, create like convert an existing API call to an MCP server. So, can it be done automatically? Yes. But when it comes to Foundry, Foundry is a place where it connects to MCP and gives MCP support, but there are ways to connect MCP servers automatically on Azure. The answer is yes. Can we use standard Azure cost estimation? Yeah, so basically you can use for all pricing purposes, we would recommend you to use Azure pricing calculator. Uh, Next question is, you should use a knowledge graph. Semantic search is only good for simple applications. See, basically, knowledge graph again for specific use cases. Um, Knowledge graph does add latency in some of the use cases, right? Because it traverses through the nodes. So when we actually work with knowledge graphs, we do try to analyze whether a knowledge graph is truly required, and in those cases, yes, knowledge graph is, but not all use cases require knowledge graph. So it all depends as per use case. Can I create an agent that will use OpenAI 5.4 Mini based on user interaction? So see, you can create agents. So every agent can connect to a different model. That is possible. So the answer is yes, you can create multiple agents with um, multiple models created. Um, there is also a concept of model router in model catalog, wherein based on the request that the model router gets, it actually decides on its own which model to hit. So you can go through this concept if you're interested. And yeah, how long are the threads retained? So basically, these are like created within Azure. So as long as you don't delete it, those will be retained for you at the background. These threads are stored in a managed Cosmos DB by Foundry. And like I showed you in that slide where there is bring your own storage, you can also specify your own Cosmos DB, and that's where you can do the management of the storage also yourself. So both options possible. They can be retained for as long as you like. Yeah, so I think I am almost, I don't see any more questions in the chat. Maybe I'll just go to the next slide. Yeah, so Please do scan and share your feedback for today's session. At least I had fun doing the session. I hope you had fun in listening to it, participating in it. Um, and uh, do go through the other sessions that we have in this series, are very engaging and very innovative. Happy to have you in these sessions. And yeah, there is one more QR code. This is an exclusive batch to display on social media. So yeah, do download the Genius certified batch. You can scan the QR code and download and save the batch, and then add it to your LinkedIn profile. And don't forget to add hashtag MSAI Genius. Yeah, yeah. With that, I think we're done. Um, yeah, Isabel, you there?
Yes, all good for now. So, thank you so much for everyone who joined from home. This session has now come to an end, and we hope you all have a wonderful rest of your day. Thanks, everyone.